This lesson is from Mrs. Cucci's College Now Contemporary Math class. Today we're going to be talking about basic set concepts. So the first thing we need to discuss is what a set is. So a set is basically a collection of objects whose contents can be clearly defined, okay? So, and for sure, it's a collection of objects. Okay, so the next thing we need to talk about are elements. So basically, those elements that make up the set, the objects that make up the set, are your elements, okay? So they're the objects in the set. So we've got a couple of methods for representing sets, so that's what we're going to talk about next, okay? All right, so one of the ways that we represent sets is by using capital letters. Okay, so a capital letter is generally used to name a set. So we could say that we're going to call all of the days in the week the set W. Okay, so capital letter. Another way we can do that is by using a word description, as well as a second method, which is roster method, and we're going to use this one quite a bit. Okay, so roster method involves listing all the elements of a set inside a pair of braces. So you're going to use braces when we're talking about roster methods. So you're just listing out the elements of the set or the objects in the set in those curly braces. Okay. All right, so representing a set using a word description. Write a word description of the set: Washington, Adams, Jefferson, Madison, and Monroe. So I want a word description of what those objects actually mean to you. So we could say that this list of objects, set P, is the set of the first 5 presidents of the U.S. All right, so that's how you write a word description for a set. All right, so how do we represent a set using roster method? That's the next part. So let's say set C is the set of U.S. coins with values less than $1. Express the set using roster method. So we have to think about all of the coins that are less than $1. And the set is going to be called C. All right, so my lowest we know is a penny, then a nickel, then a dime, and a quarter, and a $50. So once I put that into curly brackets, that's roster method. Okay, so not too difficult. All right, so a third method of representing a set is with what's called set builder notation. So using this method, the set of the days of the weeks can be expressed a little bit differently. Okay, and this, again, this is set builder notation. So we said the days of the weeks we were going to use W. So curly brackets, so kind of is a combination of that roster method as well. Now, how we're going to say this is X such that. That's what that vertical line means, such that. X such that X is a day of the week. So X meaning like the object in the set. So the object in the set is a day of the week. Okay. Hopefully I haven't lost you. All right, so we read this as set W is the set of all elements of X such that X is the day of the week. So the set W is, we know is equals in math, the set of all elements in X such that, there's that such that, X is a day of the week. All right, so let's start putting these into different forms. My first word description, B is the set of members of the, now look at, I've lost half my word. B is the set of members of the Beatles in 1963. Okay, you probably won't know the answer to this, so I'll do it for you. The roster method, again, you're going to be using those curly brackets, so B equals, and we're going to list them off. We'll say George, John, Paul, and Ringo. That's roster method. Set builder, again, you've got your set B is X such that X, right? We're always starting that way. And then kind of a description about what we're talking about. So X was a member of the Beatles in 1963. So you're using a descriptor of what you want to talk about. All right, so let's work backwards here now. All right, roster method. So I've got the set S is Alabama, Alaska, Arizona, Arkansas. So what are those? So what a word description of what that is. So I would say that S is the set of states that start with A. That would make sense, right? So how do we build that into set builder notation? X such that X, right? So we could say is a U.S. state that begins with A. So this set builder notation is very similar to your word description. It's just a different notation. All right, so if you don't have that copied down, pause the video, get it copied down. Okay, converting from set builder to roster notation. So we're going to express set A, where X such that X is a month that begins with the letter M. So we wanted to use roster method here. So we're converting from set builder to roster. So I need a month that begins with M. So January, February, March, April, May, June, July, August, September, October, November, December. So those are your months that start with M. So it's that simple. It's just going from a descriptor to the objects or the elements. All right, so the next thing we need to talk about is the empty set. So the empty set is also called the null set. Null, okay. It's the set that contains absolutely no elements. So the empty set is represented by either these empty brackets or like a 0 with a slash through it, okay? So we have to be able to recognize these empty sets. So which of the following is the empty set? So this first one is we've got curly brackets with a 0 inside. So that can't be an empty set because 0 is an element in the set. The next one we've got for B is 0. 0 is a number. It's not a set, so it can't possibly be the empty set. It does, however, represent the number of members in the empty set, but it's not actually an empty set. Okay, so it can't be that one. X such that X is a number less than 4 and greater than 10. All right, so let's think about that one. Less than 4 and greater than 10. So a number less than 4 is like 3, right? Greater than 10 would be like 11. Because some elements belong to this set, it can't be empty. We do have numbers that are less than 4 or greater than 10. So it can't be that one. Okay, X is a square with exactly 3 sides. Now let's think about this logically, right? 3-sided figures are triangles. They're not squares. So D has to be my empty set. All right, so we get into some notations here. The symbol kind of looks like an E, okay? I know that's kind of ugly. Is used to indicate that an object is an element of a set. So that looks like an E because it stands for element. It's an object that's an element of a set. This symbol is used to replace the word an element of. Sorry about that. I didn't mean to put that slash there. I got excited and went a little nuts. Sorry about that. So it says an element of. This symbol here is used to indicate that an object is not an element of the set. So it's used to replace the word is not an element of. So we're going to learn how to use these. Determine whether each statement is true or false. R is an element of A, B, C, D, E, F, G, H, I, J, K, right? Those dot, dot, dot means everything in between. So is R an element of, looks like, the alphabet? Well, I would say that's true because R is included in the alphabet. The next one, 7 is not an element of 1, 2, 3, 4, 5. So if you don't see 7 in here, it's not an element. So we're saying 7 is not an element of, so that's also true. We know 7 is not an element of this specific set. A is an element of A, B. Okay, we have to be cautious here because this is saying the set A. If you don't see what this whole thing here, right? Notice this 7 didn't have brackets around it, this R didn't have brackets around it, but this A does. So is this an element of what is over here? Well, no, it's not. A is, but not the set A, and this means the set A. Okay, so the next thing we're going to talk about is the set of natural numbers. So if you don't remember, the set of natural numbers are your counting numbers. So 1, 2, 3, 4, 5, and so on. Okay, they're your counting numbers. It does not include 0. Okay, so we're going to express each of the following sets using roster notation. So again, we're going back to that, practicing that roster notation. So set A is the set of natural numbers less than or equal to 3. Okay, so A, less than or equal to 3. So all my natural numbers that are less than or equal to 3. So I would say I would have 3, 2, and 1. Okay, set B is the set of natural numbers greater than 14. Greater than 14. So can I include 14? No, because it's saying greater than. So 15, 16, 17, and all the way up. Okay, set O is X such that X is an element of the natural numbers, and X is odd. So we want all of the odd natural numbers. Okay, so we're going to go 1, 3, 5, 7, 9, and so on. All right, so let's talk inequality notation and sets, okay? So we've got to have our inequalities and what they mean. So our inequality symbol and meaning. Here's my first one. We're saying X is less than A. The set builder notation for that. So X such that X is an element of the natural numbers and X is less than 4. So this is how you would write in set builder notation. And then in roster method, 1, 2, 3. Okay. X is less than or equal to A. X such that X is an element of the natural numbers. And X is less than or equal to 4. So it's just different notation. 1, 2, 3, 4. So less than 4, so notice I stopped at 3. Less than or equal to 4, I stopped at 4. X is greater than A. X such that X is an element of the natural numbers, and X is greater than 4. So greater than but not equal to, so I got to start at 5, 6, 7, 8, and continue up. Greater than or equal to X such that X is an element of the natural numbers, and X is greater than or equal to 4. So we're going to use that 4. Now let's get a little bit more complicated. A is less than X is less than B. Okay, so X has got to be greater than A and less than B. So set builder notation for that. X such that X is an element of those natural numbers again, and 4 is less than X is less than 8. So X has got to be greater than 4 and less than 8. So greater than 4 and less than 8. 5, 6, and 7. So now this one, 4 is going to be less than or equal to X and less than or equal to 8. Or X is greater than or equal to 4, less than or equal to 8. So I'm going to use those equals now. 5, 6, 7, and 8. I'm going to include the 4 and the 8. 2 more. So now this time we're including the 4, but not the 8. And last one. So this time we're not including the 4, but we are including the 8. Okay. All right, so representing sets of natural numbers, we're going to express each of the following sets using roster method. So again, we're going back to the roster method. So X such that X is a natural number and X is less than or equal to 100. Okay, less than or equal to 100. So if it's a natural number, I know I have to start with 1, 2, 3, and I'm going to go all the way up, and we're going to include that value of 100. Okay. Now here, it's an element of the natural numbers, and it's got to be between 70 and 100. And those equal signs again, right? We're going to include the 70 and the 100. So I'm obviously not going to write them all out. That's why I'm using those nice dots in there to represent the continuation of that set. All right, so let's talk cardinality and equivalent sets. So the number of elements in a set is called the cardinal number, or cardinality of the set. For example, the set AEIOU contains 5 elements. Therefore, the cardinal number is 5. So it's how many elements you have within the set. Okay. So the definition of a set's cardinal number, I know that's very wordy, so just remember it's the number of elements within the set. That would be the easiest way for you to remember it. Okay. So what happens when we have repeating elements in a set? Neither adds new elements to the set nor changes its cardinality. So we're going to look at what that actually means in a second. Okay, so let's find the cardinal number for each of these. So how many elements do I have within the set? Well, I've got 1, 2, 3, 4 in here. So the way we write this, so n is like the number of set A is 4. Okay. The next one, set B, has one element of the set, just that 0. So again, n, in this case, B, is just 1. Now this one's a little bit different because although it only lists 5, I know I've got that ... in there, right? So I know that it continues on with all those numbers from 16 to 21 in there. So I have to include those as part of my cardinality. So I'm going to count them 1, 2, 3. So 16, 17, 18, 19, 20, 21. That's an extra 6. There's 9, 10, 11. And then the last one, the empty set, doesn't contain any elements. So that's going to be 0. Okay, I hope you guys are holding on with me. We're almost done. All right, so definition of equivalent sets. Set A is equivalent to set B, means that set A and set B have the same number of elements. For equivalent sets, N of A and N of B, okay? So basically you've got the same number of elements in order for them to be equivalent, okay? One-to-one correspondence in equivalent sets. If set A and set B can be placed in a one-to-one correspondence, then A is equivalent to B, meaning if they're equivalent, they're one-to-one, okay? Set A and set B cannot be placed in a one-to-one correspondence, then A is not equivalent to B. So we're going to see what that looks like in a second. I know that sounds like a bunch of baloney, but we'll get there, okay? So finite and infinite sets. Set A is a finite set if the cardinality is 0. Okay, so it's a finite set if the cardinality is 0, or empty set, okay? Or N of A is a natural number whose cardinality is not 0 or a natural number, and we call that the infinite set. So if it's an empty set, it's the finite set. If it's not, it's an infinite set. Equal sets. Set A is equal to set B means that set A and set B contain exactly the same elements, regardless of order or possible repetition of the elements, okay? So we symbolize equality of set A and set B using the statement A is equal to B. So let's determine whether or not these are equal. So I've got 4, 8, 9, 8, 9, 4. So again, same elements regardless of order. So this one here would be true, that these are equal sets, okay? The order doesn't matter as long as all of my elements are there. The next one, I've got 1, 3, 5 and 0, 1, 3, 5. This is missing an element. It's the element 0. It's missing. So this is going to be false. These are not equal sets. All right, guys. 23 minutes. You held in there. Okay, so tomorrow you're going to be doing lesson 2.1 practice document. So make sure that you have that ready to go. You could do it at home as well. Okay? We'll see you next video.